Hi everyone, here's the team IoT. Week 1 is coming to an end, and this year we're doing this new thing. We don't just do a weekly blog, we do 2 weekly blogs, and when we start the week and when we wrap it up. So today is the first wrap up, recap, however you want to call it, yeah, we're thinking just to give you a short overview of how the week has been. We have 3 teaching assistants with us today, and me, the teacher, Oksana. First I want to mention that I think now, like, a lot this week has been about trying to find your way to Discord, Canvas. There's been a lot of emails like, I can't get into the course, or I can't get my place in the course. So I really hope that now today, on Friday, the last of this like hiccups will be resolved, and everyone will manage to get to the course material and already start like on the first assignments. If that is not the case, please to contact me. I think my email now is in the course contact page as well. So just don't hesitate if you manage to get into Discord, at least if you're watching this. Then contact us on Discord and we'll sort it out. Then if we go on to our Discord channel, what I want you to remember is those important channels. All the links for the materials. There's been some questions and confusion, like, oh, we have Canvas, we have Discord, we have roadmap. I'm super confused. What should I do? So, but this is really everything you need, even if you can't get into to log into Canvas yet or something. You hopefully know about this YouTube playlist where you're watching us now, with all the lectures and the study guide video. And here is the GitHub and the roadmap. So roadmap, again, to guide you through the project tutorials, and GitHub, it has the code examples. And then the schedule, if you can log into Canvas, you should be able to export the latest version. Otherwise, I'm trying to always keep this this one updated here, so you don't miss any events like today's recap. Another fun channel that is rather new, right, is this voting channel that lovely TAs made. I think last year we also did it through a quiz to kind of just see how you're doing and how things are going for you, and give us like a general overview of what operating system you're using, if you're having some problems. So like here we see that still quite a large percentage of people haven't received their, at least for those who voted, haven't received their hardware, right? Or haven't set up the development environment. So it's important that you go to this one. Just search for it if you don't have it. I will also post it later in general. So please vote on how things are going for you. Then today, if you're here with us live, here are the live lecture questions chat. So please don't hesitate to ask things here, and yeah, we will address all of them after my first general rambling. What else then? I think I'm done with the.
Oksana,
Yeah.
may I also add, when you show the vote channel, some of the students they voted last week or the beginning of the week. Please update your vote if you receive your packet. So it's better to update your vote, change from no to yes. So we know about that. So that's why some of the statistics won't change, because the flow classmates don't update those. So it's good to update those as well.
Exactly. Then with the hardware, again, we still have some issues. Electric Kit has posted that partially it's due to problems with the import, so slightly longer deliveries, and they have sent some of the kits without the sensors, so just give you the microcontroller and stuff. And don't be alarmed. It's they are aware of it. If you have in your födelsesedel, I think it's called in Swedish, but like in the paper it comes in the order that something is restad, then it means that they have an eye on it. But otherwise, always just go to the Chat with ElectroKit channel and contact them directly about your order. And no worries if the sensors hasn't arrived and something else is missing, or if you ordered the extended add-on kit, because you can start with quite a lot, even with the hardware that you've gotten. And today we'll also discuss what to do if you do have nothing still. So yes. Yeah, and then of course this week is also everyone has been thinking a lot about what to build actually. So like in our roadmap, the first few steps is set up your development environment and decide what to build, right? Because that will largely define where you're gonna go from there, right? So I would like to go through like TAs. Did you see some nice project ideas that you remember from the workshops and from the chat this week, Ahmed?
Yes, sure. There were several ideas. I think one of the ideas got my eye because she wanted to try to control according to the air quality of the room, control a fan, but automate that. So she bought a fan with the remote control, and
Mm-hmm.
she wanted to make that automated, like to be on fast slow mode, and that was really nice because it's both actuating and sensing. And we also had several ideas. Everyone wanted like to work in the nature, helping birds. So there were many brilliant ideas. And also just right now I tagged the previous year good examples that the students did. So every year we collect some of the really good projects that we think that is really innovative, and we put it in a list. Those are under good examples. I think it's the first link on
Yeah,
Hall
right.
of
I made
Fame.
it
And
Hall of
yes,
Fame.
that
Yeah.
one. Yeah, exactly. So we have projects since 2020. So it's 4 years good projects of the students that they have done some innovative. Some of them are like the same, but most of them are innovative projects. So you can find a lot of good ideas there. It helps you.
Yeah, I also want to say some people ask right in the channel, like, are these good projects? Are there usually all grade A or B that are represented here? But you can see like, oh, this is just an indoor temperature and humidity monitor. Isn't that like a more standard project, right? But you sometimes can get to a higher grade if you have spent more effort on documenting, or like in this case you picked a not so standard setup maybe of sensors that wasn't not well covered in the tutorial, so you did develop sort of your own teaching material, right? And you explain how to actually do it. So the complexity and innovation of the project can have different dimensions, and in the beginning we can't say like, okay, if you do this project you're gonna get an A, because it still depends on how you document, how you're gonna present, how well you would be able to actually implement what you set on doing. And I've seen some of like this bird project, like to see how like with the camera and like if they're eating the bird feeder, right? It can be really fun but also pretty ambitious. So good to like define some kind of smaller subset, right? So you get started with something and that actually works. So don't start too ambitious either. And just see how it goes, and how you proceed. This is like an e-health EEG monitor, so also like can be fun, but can also be quite challenging with this. So that's what I was gonna say about it, at least. What about Carl Johan and Nas? Have you seen some nice ideas? You're muted.
I guess I can speak up. Yeah, so I've heard of some really interesting project ideas this week. One of them kind of stood out to me. So the person wanted to, or the student wanted to automate a series of plants that they have, and each of the plants has like specific requirements for um, like how frequently that they should be, like, let's say, watered. And the student wanted to monitor that and then do some live updates for, like, if they want, if they want to feed it on demand, let's say, they wanted to have some advanced features like that. So it's not just a plant monitor, but there's also some user preferences, some customization. So that would be like A or B project if they follow through with it, of course.
Yeah, cool. Yeah, Carl, you're muted. If you can unmute.
To answer your question, I haven't personally had the time yet to check out everyone's projects. I've been finishing up my own exams this week, but I've heard or followed the discussion in the TA chat, and I've seen the excitement amongst other TAs. So I know there's going to be some good ones out there, and I look forward to catching up during the coming weeks and engaging with the students.
Yeah, awesome. Yeah, I think that's always fun also with automation, as you say. So not just reading data, but also doing something useful with it. I saw a project idea with the 3D printer and like controlling printer jobs with the Raspberry Pi. So with the through a web server and stuff. So instead of like connecting with it physically, to control it remotely. So that could also be really fun, and it's ambitious, but I think it's also can be possible within the frame of the course. So maybe not standard, but still relatively straightforward. So also a good project idea, I think. Then if you like Carl didn't have time yet to start hands-on with the course because you had your own exams, that is also the case for, I think, for many of us. I'm also sitting with a lot of like grading theses and completion assignments and so on, and the course is designed sort of with that in mind as well. So the first week tends to be a little bit more laid back, and people are getting started, getting logged into Canvas. So don't worry if you feel you're behind. In next week, we're going to focus more on programming, right? So in all the workshops, there will be a topic of MicroPython and actually getting to program the hardware. So, but if you still have issues with connecting the hardware, right? If you're still sort of in week one, next week, we will still help you, of course, but we'll structure the workshops to first help those that are going with the pace of the course. But as you can see in the schedule, and if you have participated during week one, we really have a lot of teaching assistant hours. So and you're also a lot of TAs that are there at the same time. So there really should be enough time to help everyone. So that is the goal. So yeah, don't be shy to ask. Right. I think that was it for what I wanted to cover today. Do you guys have anything else in mind from your side?
Yeah, we had a question pop up in the chat about how to do the quizzes, and instantly other students helped out and answered the question, because it turned out that the person weren't logged into Canvas. You have to log into Canvas to be able to fill out the quizzes.
Yes, exactly. So again, the quizzes is something to do if you don't have your hardware, or if you're just feeling bored. They are mandatory, and but they are formed as assignments, and you're using Canvas to sort of see if you have done it. So it is individual, so it's not just to click through. So yeah, this you should see it like this if you're logged in, and then click on it and be able to take the quiz. If you don't see it, that means you're not logged in or some other problem. And here also on this, like in this view, there will be a possibility to submit your report later for peer review, submit your peer review, and then finally final report. So all of your assignments should be here, and all the deadlines for assignments should be in your personal Canvas calendar, also to remind you. And when you do log in, you also see, I think here on the side, you see all the events and what you need to do. So that is useful to to fix. If you it's supposed to happen automatically if you have accepted registration to the course. Then you should be able to then you add it out, like your login, your student login, automatically added to Canvas.
And if the students can't log in, who do they contact?
They can contact me, basically, if they still can't contact. We have then administrators that help with this. But yeah, that's one of those few questions that you can just tag me in one of the question answer on the channel on Discord. That is still better than email. I mean, if you must, you can you can email, but otherwise, yes.
And the login information, when they register, where do they receive the login information for the Canvas page?
I think that is a little bit different depending on where you're coming from. So like if you're already studying at Linnaeus, then it will be your student credentials, the same as you have at LNU. If you're from another university or not studying at all, then when you accept the course registration, there should be a flow to also create the credentials, and that happens through Ladok, if I'm not mistaken. So that email that you have in Ladok, so check check what you have used there. Like if you're missing emails from us somehow, then that's where it should be. So your Ladok email.
Do we have any students auditing the course this year, as in not taking it officially or through the Ladok system? Because I remember last year that was the option of auditing the course. Are there any registered for auditing this year?
Not that I'm aware, actually. I can check it. I think it was very popular, and we have still some people in in the waiting list, which are trying to get in. I think, I don't think anyone is like officially just auditing the course, as I'm aware.
I think auditing was a part of Discord. Auditing was a part of Discord, not a part of Canvas or registration. So I think this server is free to join. So everyone with having the link to the server can join the server, so they can be audited. But then they don't get they can follow the course material. So that's what auditing means from last year and the year before.
Yeah, exactly. I think also, like, if you are auditing, I don't think you need to register anywhere. And as you see, like, the playlist is free, the Discord is free to access. You can join workshops and everything, but not. We don't really keep track of that.
You can basically do the course, but you don't get any official points in the or what, study credits? Any credits?
Yeah,
for it?
Any credits, exactly.
Except for the fame and honor of having partaken in one of the greatest
What
courses.
about the knowledge?
That too.
Yeah, exactly.
But we had an addition from Nas here about logins in Canvas. Do you want to tell us, Nas?
Yeah. So one of the issues with Canvas that you might notice is, let's say you're trying to complete an assignment, and then you click on the assignment and it gives you some weird error saying the assignment you don't have access, but you're a student in the course. This can be because maybe you last logged in like several days ago or a week ago, so the login token has expired. So you might need to just refresh and like log in once more to Canvas. So that can happen. Or maybe the page, you haven't refreshed the page in a really long time. That's another issue. So you might need to refresh the page again. So these are like just typical problems with Canvas.
Cool. I think there is one more, like more technical question about MicroPython.
Yeah, I'll read it out loud. There's a student having a problem importing MicroPython libraries, specifically the library machine, and is asking if there's a link they can use to get over this hurdle.
Yeah, I think I can start with like, yeah, maybe you haven't set up the dev environment correctly according to the tutorial, because then everything should be there. So maybe go back and look at that. What do you guys think?
So I don't think you have the, so you have to differentiate, we have to differentiate two things here. So the first is your local computer. So your local computer is like one machine, and then the Raspberry Pi Pico is a separate machine. So this is the microcontroller. So the microcontroller, you'll be able to use that library for controlling the different pins, for example, on the Pico. But on your local computer, if you're trying to run a script where you're trying to access pins through your local computer, that will not work because your computer is not like a microcontroller, let's say. So that could be a problem with the development environment. Maybe you're picking your local computer to run that specific script. Let's say you're trying to access the DHT11 through your local computer. That will not work. So you need to select the correct board. So you need to select the Raspberry Pi Pico through, let's say, the USB port to run that script.
Yeah, exactly. So I think now is actually a pretty good flow into what I wanted Jonas to show us today, right? How do you get started with coding, right? With MicroPython and trying all these coding examples if you maybe haven't set up your breadboard that you showed, like because you don't have the hardware or because you don't know yet how to do that, right? So you're gonna show us something today, right? So I'm gonna remove everyone else from stage and give you the microphone. All right. You're muted again.
All right. So I guess it's time to show you a little demo. So let me. So this is specifically aimed at people who don't yet have their hardware. So ElectroKit, for example, you've ordered but it hasn't quite yet come in, or you don't have the microcontroller yet. Maybe you haven't even purchased it yet, but you want to get started. So no problem. Let me just grab the link here from the admin chat. So I prepared a little tutorial for you. It's about like simulating the RP2040 or the Raspberry Pi Pico with this open source online simulator. So I'm going to be sharing this in the chat here in the live lecture questions. So I think I can also put this in the maybe the announcements just for now, or no, I don't have access to this one. Maybe in the important links, I'll just put this here. We can remove it later. Okay, so let me share my screen. So % share screen. Let's go to Discord. All right, so in the important links, I've shared this link here, also in the chat for the live lecture. It says mini tutorial emulating RP2040 with Walkbee. So we can click on that. So now we can go to the tutorial. So essentially, the issue we have is that we don't have the hardware, but we want to still get started with the course. So there's this online open source simulator, and it's for different microcontrollers, but it also supports the Raspberry Pi Pico W. I've provided you a link here of how we can get started with this. So this is a link to a MicroPython project. So we can click on this link so we can share the tab. So over here, we have a left side of the screen and a right side of the screen. So the right side of the screen kind of shows the hardware, and the left side of the screen shows the the Python code that we want to run on our device. So currently it's quite bare bones here. Typically the layout of the Python program at the top, we typically have libraries and let's say function imports that we want to obtain from either standard libraries or custom libraries that we have. For example, we can hit Control or Command S to save our project. So we'll just save this, if you can see this, as let's say MicroPython practice. And it will maybe give some random numbers so that, since it says it's public, so maybe give a few numbers after it, just so that people don't automatically come to this when they search. All right, so here we have just the time library, for example. This is for usually like timing. So for example, you can use this to run a function and then make the board wait for a while before it runs another function. So I want to demonstrate an example where we blink the LED through this simulation. So let's go back to the tutorial. So the first thing we need to know is that this Raspberry Pi Pico board has something called a pin layout or a pinout diagram. So if we can increase the size of the screen, so you can see that there's a series of physical pins, 40 of them to be exact. So 1, 2, 3, all the way around counterclockwise. So the left side is like odd number. Actually, no, this one's a little bit different. So yeah, the left side is from 1 to 20, and the right side is 21 to 40. And then each of the physical pins also has a number of labels. So you can see here GP0. So that's been so this is kind of how we use MicroPython libraries to interact with the pin. So this green label with GP0 indicates a general purpose input-output pin, which we're going to be using today. But there's also other pins for different types of communication. So you can see pink, so that's for SPI, and then there's like different ones here. And there's also some other pins that indicate, for example, this 3V3. So this is the power outputs from the Raspberry Pi Pico W board. It outputs a 3.3 volts volts of power. And then we also have the ground pins, and there's a number of ground pins that we can use, and you can use any of them. So this is the first thing that we need to be familiar with to be able to use the simulation. So now I'll go back to the walkway, and here we can see when we hover over these pins, this doesn't support all types of communication because it's an experimental feature technically still, but we can use it to get started. So for example, we have our ground pin here, and then we have our 3 volts pin there. So I'm going to start by adding a breadboard. So if you see the plus button, I can add a breadboard to the screen. So I'll add a breadboard. And now I want to place the Raspberry Pi Pico because it's just hanging. I want to place it onto the breadboard. So I can click on it, and then I can hit the key R to rotate. And I want to rotate it in this way, and then drag and drop it to the pins. So one is in the C row, and then one is in the H row. So it's kind of similar because when you're connecting the physical hardware to your computer, you want the USB end to be kind of off the breadboard. So that's the first step. Now the second step is I want to now I want to wire the 3 volt. So we have here the 3 volt. So on the breadboard, these columns can be seen as one wire. So each column is kind of one wire, and they're physically connected. Likewise, the bottom ones are also physically connected. However, the top columns do not touch with the bottom columns. So normally, let's say we're on column 25. So all of these let's say holes, they all share one piece of metal. So they're all touching each other essentially. Likewise, the bottom row is also touching each other.
So,
however, these do not normally connect.
It means that it doesn't matter sort of which you pick on top or in the bottom, but they will kind of...
If you would like to connect the top and the bottom row, so normally these don't connect, as I'm saying. If you want to connect the top and the bottom row, typically you have to make a physical connection between the top and the bottom. Now, this whole column will be connected actually. So it'll be something like that, exactly. So you need to actually physically connect the two for these to connect. So this is kind of like fundamental breadboard knowledge that you need to know, like it's part of the terminology for the course. So that's kind of, otherwise you might be a bit confused about what I'm doing here. Anyway, so that was kind of an aside, but important. So next, let's connect the power. Typically, we use these the top row that goes horizontally. So on the breadboard, this top row is all connected. So these actually, the whole thing actually connects. So I should use different color for this. We should use red, and try it on your board as well. You should try to use meaningful colors. I'm trying to right click, and the right click is okay. Hold on, let's get the mouse. I have the mouse right here, so maybe this will improve things. Oh yeah, here we go. There we go. So I'm trying to get the red color here. So typically, the whole these are called the rails of the breadboard. So currently, there's going to be, since I connected this the 3-volt pin with the top row here, this whole row is now connected to 3 volts. Now I want to connect the ground. So the ground pin is here, for example. I can use that one. I can use any of them technically. So we can connect it again. And now this whole row will be grounded. So these are just like some fundamental concepts that you need to know. Maybe I should skip over this for the sake of time. But this is important. Oh, so this is important. Otherwise, it becomes hard to kind of follow if you're just a total beginner. So now another thing that's common to do is you can connect the top row to the bottom row using other cables. So I just want to make sure that all of the rails are connected so that I can make full use of my breadboard. So now I'm connecting the ground row the ground rail at the top with the ground rail at the bottom, and the power rail at the top with the power rail at the bottom. Now everything is kind of fully connected. And now we can get started. So let's go back to our tutorial. So we can go back to 100% zoom. And I want to now use MicroPython to power on this LED here. And for that, I've picked this general purpose input-output pin on the bottom right corner. And we need to provide a digital signal to the LED. We're going to place the LED with, so the LEDs have something called polarity. So some components have, it doesn't matter how you wire them, but for other components like sensors, it's kind of important how you wire them. So you need to pay attention to what the pins are. So on the LED, we can first search for an LED by adding a new part. So I click the plus and I see that there's an LED here. So I can take the LED. I can drag it. I can assign a different color to it if I want. In this case, I just wanted a red LED. So let's pick a red LED. I'm going to connect it to, I think, let's see, where do we connect it? We connected it to pin 30. So it's going to go on pin 30 here somewhere. Here on the LED, you can see that the A lead on the right is kind of longer. It's also bent. So that indicates that needs to receive I think that's the anode, and it needs to receive like a positive signal. So that should be closer to the power than the ground, whereas like the shorter one needs to connect kind of towards the ground side of the circuit. So I want to take a wire to connect the LED to pin 30. So this can be our wire. So this will connect to general purpose input output pin number 16. And now let's put our LED there with the positive end closer to where we're going to be supplying the digital signal. Now this needs a return path to ground. So, and the other thing with the LEDs is they often need a resistor to kind of reduce the current. Otherwise, there's too much current running through the LED. It can be either too bright, or if it's too bright, it heats up and it can burn. So we're going to add a small resistor. So we click the plus button and we see the resistor. So we pick a resistor. So we can zoom out a bit. We pick our resistor. We can rotate it with R. And we can drag and drop it. So I can assign a value to the resistor. So typical values, I think ElectroKit sent you 330 ohms. This is kind of like the right value for, I mean, 220 is fine too. But this is the correct value for the resistor. Now, it doesn't matter how I place this. I can place it with the orange. So the resistor values are typically color coded, and there's explanation in the terminology part of the HackMD tutorials. This is not important, but we need it in our circuit, so we can place it over here. So in this case, the ground-facing pin of the LED will connect with the resistor. So we kind of connect it across to make a physical connection between the top column and the bottom column. And then now we need to just connect it to the ground. So we can just connect it to the ground as so. And now everything should be connected. So we can go back to our HackMD tutorial, and we can kind of look at the schematic we had there, and it looks kind of consistent. So now we need to set up our code to kind of work with the tutorial. And here I actually have the completed one that you can just click on if you're joining us late. So you can also click here if you haven't been able to follow for the final product. So I'm going to be copying this code here, and I can go back and paste it into the tutorial. And essentially what this is first we import the libraries, including the machine one that we had a question about earlier. So the machine one allows us to define and to make use of pins on the microcontroller. The time library is good for timing. So first we create a variable called red LED, and we make it equal to a pin object that is connected to pin GP16. So general purpose input output. These pins are usually labeled by the integer numbers there, so like 16. And we label it as an output pin, which means that we are going to be outputting a signal, a digital signal from pin 16. I'm not sure, I don't remember exactly right now if we can do analog signals. I think we can though with the Pico, but I don't know if they have a different notation or not. But this is, I think, a digital signal. And then we enter a loop because we want our LED to turn on and off. So one moment, just trying to power on the other.
Are you doing the physical one? At the
Yeah,
same?
I have the physical one here too, sorry. Yeah,
That's
so I just want to show you kind of.
Yeah, but it's really nice because here you can start basically very low-key, even if something doesn't work on your computer and you want to try one of our tutorials, you basically can just do it in the browser. And you can save your projects on this website for later. You can share them just like Nas did with this tutorial. So basically, don't let ElectroKit stop you from going through the course.
So the while true is then basically an infinite loop. So I want this to turn on the red LED and then make it go to, or just like kind of after you turn it on, you want to wait for 0.3 seconds to create a nice like blinking effect. And then you can turn it off, and then you can wait, and then it'll come back, and then it will do it again. Because once it enters the loop, it kind of runs forever. Oh, I should clarify. Usually these scripts for MicroPython or Arduino in general, they have two parts. So the first part is kind of the setup. So that's kind of everything up here, and that usually runs once. And then usually you enter some sort of loop with the microcontroller. And these are the things that you should do periodically, and that will run many times. So now we can start the simulation. To start the simulation, you just click the green button, and it should do as you kind of told it to. And then you can take this code, and then you can import it to Tony, let's say, for example. So let's go to Tony.
Yeah, so Tony is another development environment, so which we have suggested.
Yeah, I'll stop my screen for a moment, and then I'll try to share a different window.
Carl is going for a walk here at the same time, so it's very distracting.
Yes, it's nice. Yeah.
You're gonna install some sensors in the forest, Turco.
Okay, so I can't share my screen for some reason for the Tony. I guess StreamYard doesn't allow me to wait. I see it now. Yeah. Okay.
The doggies.
So I can essentially use Tony.
Let's see. I'll add you to stage now. Here we go.
Yeah. So then, let's say this 0.8, and then here in Tony, I'm not sure if you can see when I select the board in the bottom right. Can you see that?
It's a little bit small, yeah. But you selected something board.
Yeah. So for example, this is local Python. So if you're using local Python, you'll see that you're in like your C drive, for example, in Windows. So this will not work. You need to make sure the firmware is installed, and then you can go to the bottom right here where it says local Python. You can click on it and then click the MicroPython. And now it will say, yeah, okay, now we are using the Raspberry Pi Pico W, and then you can use the machine library. Yes. And then to upload it to the board, make sure it's connected. And then you can click this run current script or F5. And then when we run that, we should see our board lighting up as so with the same. So essentially, it's a way for you to simulate the, I guess, some sensors with MicroPython.
Can you show the board again? How it's blinking?
Yeah, of course. I think it should be mostly consistent. So yeah, it's kind of doing what I programmed it to do, which is the expected behavior.
That's really cool.
Yeah. So that's kind of my tutorial for today.
Yeah, I'm really happy. I don't think we have any more questions about that. We are except that we are saving this, and all of the kickoffs and recaps are saved, and I'm adding them later to the both the playlist and the course page, the lectures in Canvas. So I just thought it's important. Here's another question. How well does microcontrollers and sensors work outside, considering humidity and heat and such? Is it best to have them in air-sealed containers, or ventilation is preferable? Will things rust or shortcut instantly in damp weather? And I think I have seen a question like that before. People are thinking to do something, to set something up outside, but how do I not ruin my camera sensor or other electronics pieces? So what do you guys say?
It depends. It depends on the environment that you're using, how humid or damp it is. So I mean, you can buy some of the boxes from Biltema here in Sweden. So they are designed for outdoor, so you can use those. I mean, usually you can do 3D printing those, but if you don't have seal it around with the this silicone rubber, so it's not gonna be airtight. You don't need ventilation for microcontrollers. unless you have like high load and it's just really tight, so you cannot wrap it, but it's rather that put it in a box so it has some air around it. But then it shouldn't be airtight. I would say that it will survive if you put on the one of those boxes that are designed. It's gonna survive for a long time. I think Carl had it before outside in the woods. How was your experience?
Saying that I kept it outside would be a bit of an overstatement, but in my general experience, I'd say that for the duration of the course, unless you're trying to submerge it, then just buy a food storage container that seals tightly and make holes for cables and figure out where ventilation holes would go, such that water can't ingress. When I designed mine, I used additive manufacturing and made sure that every ingress port had an upwards facing channel, so to say, so that water couldn't get in. And I had, like you said, a gasket to seal the lid. But I can't say that I know exactly how to follow like IP standards to make sure that nothing happens. I mean, for the duration of the course, 5 weeks, probably not going to be a problem with oxidation, even if you keep it in a rather humid environment. But I'm not making any promises, so your individual experience may vary.
Yeah, I would also say it really depends on the project, really depends on the sensor, right? So usually those more like industrial grade sensors that are for outdoor use, and they have kind of thought that through already with this. They have certain cases, and even for those like if they're running on battery, the battery life will be reduced if the temperatures are low or if it is very humid. So that is always always a concern. But yeah, for the course, maybe it doesn't matter as much, and you will probably start whatever your project does. You will probably start on the breadboard on your desk, and as long as you demonstrate that that it is working on your desk, that is sort of good enough, I think, in my opinion. Then obviously, if you wanted to benefit from your project and use it. Then you need to spend some more time thinking through your bubble wrapping and other strategies, right? Yes. Andreas writes here, I just want to add that the tool NAS is presenting is great for just doing layout work and scheming, but if you have a more complex project, don't discard it as a simple learning tool. It works well to just map out your project and lets you try out. Yeah, so exactly. I mean, this is more of a suggestion of what to do when you're just getting started with MicroPython, with our tutorials, and with familiarizing yourself with the components. Of course, you can't really, it will be difficult to do like your whole project in this tool, so don't do that. It's more of something to do now in the weekend while you're waiting for your electric kit orders to arrive, basically. Yes, I think we will wrap up unless you guys have something else to say.
Yes, Oksana, may I add something? During this week, some of the students, they had issue with some of the libraries we had for the code. Some of the recorded lectures have been recorded last year. And then back then we had another version of MicroPython. It was a PyCon MicroPython. And for some of the sensors, specifically the ones that every students receive from lecture kit is DHT11. It's a blue one, and is the one with the temperature and humidity sensors. If you follow the lecture videos and if you have issues of reading, please follow our GitHub and also the HackMD tutorials, because those are updated. The video lectures are recorded last year. We had another version of firmware when it didn't have the library built in. Now the library is built in MicroPython, so you don't need to import any libraries. So I just wanted to volume out. So Neda, I think she also tagged all the students and she described about that. So please do that. So like follow our GitHub, its latest version. And if Oksana, you can share, it's an important link. And we have also a small image of all the sensors that you receive from ElectroKit. So you should be like good to go if you open that one. So you know that each sensor, what they will do, and also short code for how to use them.
Let's see if I can.
If you go down, we have images of all the sensors, and beside the blue links is the small examples of how to use them, and also the connection. If you click on one of them randomly, so you can see on that specific page, if you go below, yes, this is a connection, how you can connect. For all the sensors, we connected to one port, but then it gives you an idea how to connect those sensors. And also main.py, we have the code inside.
Yeah, exactly. So these are all the things to try, and it doesn't mean that all the lectures are obsolete and you shouldn't look at them, because they're still relevant in general, especially if you need the basic knowledge of all the components and how to read this pinup and all the stuff, right? So that still will be the same, but it's always a challenge in this distance courses. We want the lectures to be good quality, and it takes a long time to record them, and then in the programming world everything gets updated every few months. So we really, what we do is then we make an effort just before the course to update all the tutorials, to try all the code with the latest version so it works for you. But yeah, lectures is a bit of a slower process. So I think in general, what we try to do is to keep the practical part, take out the details out of the recorded video material. But yeah, so no one gets confused. But the roadmap and the GitHub and this live sessions is your go-to for hands-on work, so you don't get stuck trying something that is older. All right. Thank you guys for today. Let's wrap up. It's been always like longer than I think with these sessions, but I think it was very good. And thank you for coming. Thank you for students who watched live, or if you're watching it during your long weekend. And we'll see you on Monday when we will start a new week that will be fully focused on programming. And you now have 2 quizzes to complete already to check your knowledge on both the basics of IoT and programming. So thanks a lot, everyone, and see you next week. Bye.
Bye.
We have